Alright, hope this is recording. This is the Envirothon COVID 2020 soil session. I'm knee deep in water in the soil pit. Jim Tureen, Assistant State Soil Scientist, Rhode Island USDA Natural Resource Conservation Service. I'm also being joined by some honeybees, which are in the water, drinking up on the puddle, so I'll have some company today. We should already know coming into the pit by using our off-site reference materials that we are in a soil series or map unit called Rainbow Soil. It's an RAB map unit, Rainbow Silt Loam, 3 to 8% slopes. That's a moderately well-drained soil formed in aeolian loess material, silty loess, underlain by dense lodgement till. So I'm going to go through what we would be doing had this been the Envirothon test site. We actually used this site a few years ago for the Envirothon, and we would have part of the soil test would be to have the students or the teams hop into the pit, look at the soil layers, and record some of the basic things we look at soils: the horizons, the color, the soil texture, and then make interpretations about this soil. Is it prime farmland? Does it have limitations for certain uses? And so on. So I'm just going to go quickly through and show what I see when I look at this soil. The first thing we do is start clearing off a face and looking for different layers in the soil. We refer to these as soil horizons. Horizons are layers of the soil formed by pedogenic processes. These can include additions, losses, transfers, and transformations that occur within the soil. You can make a break for horizon for any purpose. Differences in roots, rock fragments, color. If you start seeing those redoxymorphic features, you would want to break that out as a horizon. So my first one is going to be my A horizon, and you can see there's a fairly abrupt boundary and a color change. Oh, I'm stuck in the mud. Between the A horizon and the underlying, I guess my boots are not waterproof, limitation of the soil here. A horizon, basically it's a mineral horizon that has dark colors due to the mixing of organic material. So carbon, the mineral and organic material, is given the soil this nice dark color, kind of a brownish color in through here. The next horizon down, I'm just doing master horizons, and soils are pretty easy, A, B, and C. The next horizon, you can see there's a color difference between that and the overlying A horizon. That's going to be the B horizon. The B horizon is an alluvial horizon that has evidence of soil formation. Something is moving in or changing the soil to give it, in this case, color development. So the color we see here is iron oxide coating the silt, sand, silt, and clay particles, giving us this nice yellowish-brown type of color. The next horizon down, we abruptly go right into a very dense layer, unweathered, just gray-colored material. This is the C horizon. This is that soil parent material in which the soil formed in. This is the dense glacial till material, very sandy, a lot of gravel, coarse fragments. Till is unsorted, unstratified material deposited either within or beneath a glacier. So 25,000 years ago, I might have been under close to a mile of ice, and that laid down this material through here. All right, take two. I'm going to be showing you the basics of How to describe a soil profile. Normally, if we were doing the Envirothon test in the field, part of your test would be to hop in a soil pit that we would dig out and have you describe the basic soil properties, horizons, texture, and horizons, color, and texture, and then make interpretations about the soil, whether or not it's a wetland soil, is it prime farmland, what are some of the limitations for various land uses, and then probably something relating to the exam or the test question. A little warm. You'll hear the bees buzzing. They're drinking the water that's in the pit. So the first thing we do is look at the different layers we see within the soil. We call these horizons. Soil horizons are layers of the soil approximately parallel with the Earth's surface that are formed through soil forming processes. Additions, losses, transfers, and transformations. We're just going to have you look at the major, what we call master horizons. And in soils, it's very easy. A, B, and C. So if you know your A, B, and C's, you're pretty good at soils. First layer we usually have up on top, if we're not in a wooded area. If it is wooded, we would probably have an organic layer up on top from the leaves falling on the soil or on the surface. This soil is out in an agricultural field. So our first layer is an A horizon, also called topsoil. And that's basically characterized as just having its mineral material that has dark color due to the mixing of organic material, humus and carbon. Carbon is actually giving it the dark color, that's the element, giving it the color. And this is a result of farming that's been occurring in the area. The farmer is trying to build the soil, mixing in organic material, usually manure or some other material that will give it this nice dark color. So that would be the A horizon, very abrupt boundary between that and the next. That's due to the plowing. So sometimes you'll see an AP horizon. The P just tells us a little bit more about the master horizon. So the superscript is tells us a little bit more, or subscript I should say. The next horizon down, it's this nice yellowish brown colored horizon, and that's the B. That's a B horizon. So that's a pedogenic horizon that has alluvial material. It's evidence of illuviation, or something moving in and changing this material from its original, when it was originally laid down or formed there. So in this case, in our neck of the woods, the pedogenic process we usually see in our upland soils is just the addition of iron oxide, which is rust basically coating the sand, silt, and clay particles. So it's giving it this nice yellowish brown color in the soil. So that's the B horizon. The next one below, very dense. You can see I can easily go in here, and then I hit here. I'm having issues digging in. This is a C horizon. So the C is your unweathered geologic material in which the soil formed. This actually has some redoxymorphic features. Some of the blushes of iron and gray within the soil. So the C is just your unweathered geologic material the soil formed in. So before we came out here, we did review the soil, or the reference materials, the soil survey, for example, which I can pull up on the soil web right here in the field, and it's going to tell me that this is a rainbow soil. And if you read what the rainbow soil is, it's a moderately well-drained soil formed in Aeolian loess material underlain by dense glacial till. So this is a glacial till type of soil. That's the C horizon. It's actually a CD horizon. And the stuff above it is a post-glacial deposit of Aeolian or loess material. So we actually have two parent materials within the soil. But the C horizon is responsible for the water table I'm standing in here. It's basically water moves through the soil when we get a rain event, and it moves pretty rapidly through the A and B, what we call the solum. And when it hits this dense layer, it kind of gets perched up on that slowly permeable layer. So if you read the properties of this soil, it'll mention it has very slow permeability in the substratum, and that's what's causing the water table here. So this water that we see here is usually only here from late December until early June, Once the leaves and evapotranspiration kicks in, this water disappears and we go into pretty much dry. So if I were to dig here in July, August, it'd be bone dry for 10 feet without hitting water. Some of the other properties we look at is the color. To document color, we use the Munsell color notation. This provides us a scientific way of documenting the color of the soil. I could say it's yellowish brown, someone else could say it's brownish yellow. This actually gives us an exacting way to document the color. And the way you use a color book, our neck of the woods, I like to start on the 10YR page. I'll take a soil ped or a piece of soil out, and basically you're just trying to match the color with a chip. Seems easy enough, but it does get quite complex, particularly when you are trying to decide exactly which chip it is. So let's just say for purposes, I like this chip to match the B horizon. The way I would note it using Munsell color notation, it's on the 10YR page. Each one of these is a separate page. 10YR means the YR is yellow-red. Then we document the value, which is on the vertical axis, and then a chroma on the horizontal axis. So again, I was looking at this chip here. The color notation would be a 10YR 4-6 color. That's 10YR, that's the hue. Value is a 4, chroma is a 6. So it's telling me a very high chroma color in this soil. The other thing we look at, horizons, color, and texture. Texture is the amount of sand, silt, and clay within the soil. There is a flow chart in your study guide that will show you how to do texture. Of course, this year we won't be able to do it, but normally we would have students have a bucket of material and ask them to determine what the USDA soil texture class is. So in this situation here, again, we're looking at our soils having very low clay percentage, so they don't have that stickiness associated with clay soils. This has a nice creamy, smooth texture, no grit at all, but it's not sticky. So this puts it into that silt loam class versus the C horizon. You can almost feel the grittiness. Hopefully you can hear that, but this actually has quite a bit more sand within it. So probably more of a sandy loam type of texture versus a silt loam texture. That's about it for properties. Again, we look at a whole lot more in soils. Those are just the basics, things that we look at in order to classify and map these soils. The other thing we usually ask on the test is for you to make interpretations about this soil. For instance, we'll say, is this a hydric soil, or are you in a wetland? Well, it's not black and gray, so we're not in a hydric soil. We'll ask for interpretations such as seasonal high water table. Where do you think the water table is in this soil? I don't see any of those redox features in this upper part. I did see some down in the lower part, so this does have a water table, but it's not high enough to cause major interpretations. I wouldn't want to put a house with a basement on here because you're going to get a wet basement. The other major thing we want to know is whether or not this is a prime farmland soil. So this soil has a nice thick A horizon, fine textured material, a lot of water holding capacity, nice friable material, level landform. I don't see any large boulders or bedrock or anything. So this would actually be a prime farmland soil, which we already knew by using that web soil survey. So let me see if I can hop out and show you what I'm standing in. Mud. Ugh. Sorry, bees. The bees are loving it in here. This is your water table. And again, we showed the well and stuff over there. This is usually, I've seen this come all the way up to the top of that AP horizon. I'll show a few photos of that. And then I'm going to show you what good redox features look like on the pit just to my east over there. That's it. All right, battery's running low, but just wanted to show this soil pit here. Also the rainbow, but this has a good example of redoxymorphic features. You can see the grays and the iron all mixed up. So this is a sign this soil has a water table pretty much right below the AP horizon. So we're getting wetter. I'm going to show you one more pit. That's pretty interesting. All right, here's the last pit. We stepped into the woods. Here you can see the field is right over there. Mature hardwood forest, large trees, stones and boulders everywhere. However, when we look at the soil, you can see that nice dark layer there. That's an AP horizon, so this has been plowed. This is a neat part of soils where you can tell by being able to read the layers in the soil what the former land use was here. This was an agricultural field, probably hundreds of years ago, abandoned, and now it's got hardwood trees growing on it. Skunk cabbage right there, and a wetland right over there. But all of these are the same soil, but you can see different properties associated with them. Redox features. This soil has a really high water table. Actually comes right up to the A horizon here. Borderline hydric. All right.